Following tutorials when you first get started with serverless is okay, but eventually you need to have some real practical experience. The challenge with that is that coming up with project ideas that are both achievable, but also push you and help you grow is really hard. To help, I've come up with 7 project ideas that will progressively help you become a better serverless developer. If you're new to AWS and serverless development, then start with project 1 and work your way through. But if you've got more experience, then just look through the benefits of each project and pick the one that's going to teach you the functionality that you're looking to learn. Make sure you stick around to the end of the video, as I'm going to be giving away my top secret tip to help accelerate your learning and help you become an AWS and serverless developer as quickly as possible. The first project is going to be an API which is called and then makes multiple requests to different APIs and puts the results all back together. So what this is going to look like is you're going to have an API gateway which is going to come in to a Lambda function. Now this Lambda function is going to take the request and it is going to take the parameters off that. In one example, it could be that you have an API for the cost of certain items in a game, and then you have a translation API. This Lambda is then going to make an API request to API number 1 and get back some information. In our example case, that might be getting the cost of a specific item in the game. Based on that information, it can then make a second API request to API number 2, and this will then translate the cost of the item into a local currency. Another use case you could build is an API for translating news articles. So the first API would be the news article API, and the second one would be a translation API. If you're looking for some public APIs that you could use for this kind of project, in the description below, I've made sure to link a Git repo that contains hundreds of publicly accessible APIs. This process of having a Lambda, calling your multiple APIs and combining the data is something you will do a lot in industry, where you have to call, for example, you might have to call the shipping API for a warehouse and then call the product inventory and then maybe even a CRM system as well. So getting some good experience practicing this process is definitely worthwhile. Project number 2 is going to be a URL shortener. So again, what we're going to start with is we're going to start with API gateway, and this is going to have not just 1 but 2 endpoints. So the first endpoint is again going to come to a Lambda function, and this is going to be used for adding a new URL to the system. In this request, you need to pass up the URL that you want to be redirected to. Inside this Lambda, there's going to be a bit of logic which generates a short 5 or 6 character code and stores that into a DynamoDB table. In this DynamoDB table, you're going to have stored each record with its ID, which is that short 5 character code, and then the original URL. That means when someone hits the second endpoint, which is going to be a proxy endpoint, that is going to come and hit a second Lambda function. The URL that is requested to hit this Lambda function is going to have a path parameter of that shortcode that was generated in the first Lambda. We can then get that code off from the request, look it up in the database, and when we've looked up that record, we can actually return the original URL to the user. We could take this one step further by inside this Lambda, instead of just returning the URL, we could actually return a 301 or 303 redirect, which would automatically tell the user's browser to redirect itself to the original URL. This project is good as it has multiple API endpoints, and it also introduces us to DynamoDB and how we can set and get data from it. Project number 3 is going to be a reminder app, where users can submit a reminder, and when that reminder comes due, they'll be sent either a text message or an SMS with that notification. As always, we're going to be starting with API Gateway, and the first endpoint that we're going to be adding to this is going to be to set a reminder. So that is going to be an API request that we are going to forward to a Lambda, and on this request we need a couple of things. The first thing we need is obviously the reminder message, but we also need a way in Dynamo to know who we need to send the message back to. So we also need a user, so that might be the email address or the phone number of the user, and then whether they want a text message or an email. We also need to know when they want the reminder to be served. So with this number, we can convert that into a Unix timecode and write that into DynamoDB along with all of the rest of the request data. Because we've added a TTL or a time to live onto that record in Dynamo, once we get to that time, then the Dynamo record will be deleted. What we can do is we can hook onto the back of that and say anytime a record is deleted in Dynamo, I want to send that record to a specific Lambda. In that Lambda, we can check the user's email or phone number, as well as the message, and whether they wanted a text message or an email. From here, what we can do is we can either use SES, which is the simple email service, or SNS, simple notification service, to send a text or an email back to our user, and that is the reminder that they'll be getting. This is really cool, but what happens if you want to review your current reminders? In API Gateway, we can add a second endpoint and a second Lambda, and what we can do is we can query on the DynamoDB table. To be able to query on the Dynamo table, we need to set up the schema in a specific way. What we need to do is we need to have a partition key, which I'm just going to call PK, and a sort key. And these two things allow us to query on records in DynamoDB. So for us, our partition key, which is what are we going to be grouping these things by, that's going to be our user's contact details. So I'm just going to call that user. So that might be either their phone number or their email address. The sort key is how we want to order those. Assuming you want to get back your reminders in order of when they are going to be processed, our sort key can actually also be our time to live. So I'm going to set that to be TTL. What this means is that we can now query and say, for this email address, get me all of the reminders ordered by when they are going to expire. This is really powerful, and you could build a front end for this and have a really nice application. This project is going to bring us a couple of things. The first is that we're going to be using DynamoDB streams and time to live expiry, which is a really cool tool you'll find yourself using in a lot of different places. We're also using SES and SNS for sending text messages and emails back to the end user. And finally, we're starting to use some querying on DynamoDB and learning about partition keys and sort keys. If you have liked this video, then make sure to smash that like button, as it really helps share this video with more software developers just like yourselves. You can also download a PDF which gives you all of the details that are covered in this video, from each project to the architecture, and the link to download that free PDF is in the description below. Project 4 is going to be a live chat service where users can join a room or create a room and then talk with other people in that room. So first we're going to have user number 1, and they are going to connect via WebSocket to API Gateway inside our AWS account. Now, WebSockets work slightly differently to how an API works, where instead of having lots of different endpoints, you have a single endpoint, but you can send different types of message. So there are some default ones, such as onConnect, but you can also add your own custom message types. So we're going to have a custom message type of create room. So this is going to go to the first Lambda. What this create room request is going to do is it is going to create a record inside DynamoDB, and this record is going to have both the room ID as well as the connection ID of the user, and it is going to store it into a single record. The reason we need to store the room ID is that when we have another user in that same room and they send a message, we're going to be querying and getting all users in a room to send those messages out. So how does another user join the same room? So now we've got user number 2. They're also going to connect to the API Gateway WebSocket endpoint, but this time they're going to connect to the method of connect to room. So this connect to room is going to do something very similar, but it is going to be connecting to an existing room ID. It's also going to add a record into the same DynamoDB table as the initial connection. So now we have 2 records, both having the same ID as the room ID. So what this is going to look like in Dynamo is you're going to have a partition key of room ID, and then you're also going to have a sort key, and the sort key in this case can be the user ID. What this schema allows us to do is query on the room ID whenever we have a message. So there is going to be a third Lambda connected to the API Gateway, and this is going to be a Lambda for onMessage. So this happens whenever a user sends a normal message down the WebSocket. What's going to happen is we're going to look up in Dynamo first for who is the user that's sending this message, and we'll get back the room ID as well as the user ID. We can then go, okay, we know that this message was sent to room, let's say room 123. We need to query the DynamoDB table for all users who are connected to room 123. In this case, it will bring back 2 users. Obviously, one of them is the user that sent the message, so they don't need to get their own message. But now this Lambda can go through everyone else that is connected, send a message back via API Gateway to the other user. And that is how we can create a live chat application with rooms. And if you had a different group of people with a different room ID, they could each have their own conversations all happening at the same time. For project number 5, we're going to go with an idea voting app. Now this is going to expand your experience with DynamoDB and doing many-to-many relationships, which is something that you are going to need to learn how to do if you want to be working with Dynamo in real applications. We're also going to connect Cognito to add authentication to this application. So we're going to start with our user over here. And what they can do is they can sign up with Cognito. And what that is going to do is that is going to enable them to then interact with the rest of their APIs. So in terms of the APIs, we're as always going to go with API Gateway. And this API Gateway is going to have quite a few different endpoints. The first is going to be a create board API endpoint, which is going to allow us to create basically a new board of ideas that can then be voted on. This is going to add a record into our DynamoDB table. This is going to be a relatively simple record, just with an ID of the board and then some details about the title of the board, the URL, and who owns it. The next endpoint is going to be a Lambda again integration for creating a new idea. This idea is also going to be written to the same DynamoDB database. This idea record is going to be slightly more complicated than the board one, because we need to be able to say, get all ideas for this board. So what we need is we need a partition key, and the partition key is going to be the board ID, and then the sort key. That can be basically whatever we want, but I'm just going to go with the idea ID. And this is all for ideas. The next endpoint we need to have is voting on which ideas we like. So there again, there's going to be a third Lambda, and this one is going to be for votes. Now, to be able to vote on something, we know that the user has to be a member of Cognito. So what we can do is we can write a record to DynamoDB saying that this user has voted on this idea. This allows us to then count up for each idea how many people have voted for it. The way that we do that is we have a record for that idea has been voted on by this user. So here we have a vote record, and that will have a partition key of idea, and it will have a sort key, and the sort key here is going to be the user ID. This means that whenever someone votes for something or clicks that button, we can actually check with the PK and SK if they've already voted for that idea. If they have, we don't want them to be able to vote twice for the same idea, so we'll just reject that request. If we look up the idea and the user ID combination and find that there isn't any record for that, then we can add it. This setup also means that we can query on the PK of a specific idea to get the total number of votes for that idea. This process is really good, but what happens if we want to find all of the ideas that a specific user has voted for? What we can do is we can add another global secondary index, and I'm going to call that PK2. So there's going to be a second partition key and a second sort key. So this now means what we can do is we can add the user ID as the partition key and the idea ID as the sort key. This allows us to query on the user's ID and get back all of their votes. This is a really neat way of doing a many-to-many relationship where you can find out how many votes has an idea got for a unique user, but also for a user, how many different projects have they voted for. Project number 6 is going to be a full messaging application. So this is going to start looking very similar to the live chat one, where we have users connecting via WebSocket to API Gateway. There being those same 3 lambdas for creating a room, joining a room, and then messaging. And it's all going to be looking into the DynamoDB database. So live messages are going to look very similar. The difference is going to be that there are also going to be some extra things. Whenever a user sends a message, we're not just going to send that out to every single member of that room. We're also going to be storing that into DynamoDB. The reason we need to do that is that if there is a user who is part of a room but isn't currently connected to a WebSocket, we need a way for when they do log on for them to get those existing messages. What we're going to do is we're going to use compound keys inside DynamoDB to allow us to store multiple types of data in a single partition. So in our case, our partition key is still going to be room ID, but our sort key, that is going to change depending on what kind of data we're going to be using. So in this case, we're going to be storing a message. So we want to call it message, and then a divider, something like a hashtag, and then message ID. So that way we can say, get me the partition of room ID and the sort key for every record where the start is message hashtag. This will get us back every message ID, but just the message IDs for that room. The next part of this is that because we're now persisting data, we actually want a way of allowing or disallowing users to join into a room. So now, before someone can connect to the WebSocket, we're also going to add Cognito as a sign-up mechanism so that we can know who the user is that is connecting via WebSocket. If they do a join room request, instead of just instantly adding them to the room, what we can do is we can allow the admin or the owner of that room to receive an invite request. So in this case, the partition key is still going to be room ID, but the sort key is going to be something like access. So that is going to be access request, hash, and then their user ID. With this, whoever is the owner of the room can find that user ID and look up the user if they are a user who they want to have access to the room. They can change their record. The record for that is going to have the same room ID, but this time the sort key is going to be auth user hashtag user ID, and now that user is an auth user in the room. Whenever a new WebSocket message comes along, instead of just querying on the room ID as we did with live chat, we're going to query for room ID starts with auth user hashtag, and that will get back all of the authenticated users for that room. So now when the next user logs back in, we can query their user ID and find all of the rooms that they are authenticated in, and then use that room ID to query the same Dynamo tables for room ID message hashtag. So that will get them all of the most recent messages for all of the rooms that they are in. The final project that we're going to be building is an event-driven ecom system. So to start, we're going to be having some DynamoDB tables. these DynamoDB tables are going to be containing the products to start with. And we can start by using some compound keys, as we did in the last project, to allow us to add some level of hierarchy to our products. So what we can have is we can have a partition key. I might set the partition key to be product, and the sort key, this time I'm going to start making this a little bit more advanced. So instead of just putting an ID in here, I'm going to add some categories. So first I want to start with like men's, and if I had a female product it would be women's, and then I'm going to add the hashtag here. The second stage is going to be what kind of clothing is it? Is it a t-shirt? Is it trousers? So I'm going to call this tops, and this could be trousers. And now we've got this level of hierarchy. I think that's enough for this application. So I'm just going to add a hashtag and then an ID here. What this allows us to do is say, okay, I want to get all products, and you can get every single product in the database. But you can also say, I want to get where PK is product, but sort key starts with men's. And that will get you every single men's product. Likewise, you could say, I want to get PK of product and a sort key of women's hashtag trousers. And that will get you all of the women's trousers. This is a relatively rudimentary way of adding categories and filtering to your application, but it is definitely something that I've seen done. So this is the underlying data structure. And of course, we're going to have API gateway. And to query on these, we're going to have a Lambda, which is going to be doing a get product or query product request. As well as getting products, we then need to be able to create an order. So again, there's going to be a second Lambda for create order. For these orders, we're going to have a partition key of user ID, and that's because we want to be able to say, get me all details for the user, and that will include their orders. But in our sort key, we can go order hashtag. And then after this, we might want to be able to sort orders based on time. So in here, I'm going to put in a timestamp. I'm just going to put that in curly braces to imply that is a variable. So here, I can now say, get me for a partition key of user ID with a sort key that is between order hashtag 5 weeks ago and order hashtag 3 weeks ago. And that will give me all orders placed in that 2-week window. Now that we've written a record to DynamoDB, we can actually add DynamoDB streams to this table. What this will do is this will output to EventBridge a record for that DynamoDB record. Now that it's in EventBridge, we can have multiple lambdas listening to this EventBridge for different kinds of events. So in this case, this will trigger an order create event, which will then have a lambda listening for any order creations. And this one is going to be sending an SES email to the user saying that their order has been placed. The good thing about EventBridge is you can actually have multiple different lambdas listening to the same topic. So as well as that, we're also going to have a second lambda, which is also listening to the order creation, and that is going to create a pick list in the system in the warehouse. So that's going to send some data to the warehouse. Now that that order is in the warehouse and is being prepared, everything is good. Whenever the warehouse manages to pack and prepare the order for shipping, they'll hit a different endpoint in API gateway. This will then write a new record into DynamoDB, telling us to update the existing order record, which may have a field of, I don't know, status. And that has now just changed from being something like placed to being packed. Again, because this DynamoDB record has changed, the streams will go into EventBridge, and this will now fire a different event of order packed. Now that the order has been packed, again, we can use SES to send the customer an email saying it's been packed and it's ready to be shipped. But we can add another listener to exactly the same EventBridge trigger, but this time it's going to order the delivery from the shipping company and actually get that ready. So that's going to hit their API and update their system with a new order to be collected. The final step in the process is that the shipping company can also hit our API gateway, which is going to hit another Lambda. And what that Lambda is going to do is that is going to again update the existing order, change it from being packed to now being shipped. Now that it's been shipped, again, DynamoDB streams going to EventBridge, and you kind of see, you write things to DynamoDB, it goes into EventBridge, and then that fans it out to the Lambdas that need to process it. This happens a lot. So this time it's going to come here, and it's going to be an order shipped event, which again is going to go to a new Lambda, and that is going to take SES and send the user an email saying, congratulations, we have delivered your order. You could also have other listeners for the order shipped, such as updating other Dynamo tables for your historic data so that you can say, here are all the orders that we have shipped in this time period. Using EventBridge in this way, listening to changes in your database, is a really common pattern, and using EventBridge and its ability to fan messages to multiple different listeners is really powerful, and is something that I think over the next couple of years is going to become mainstream in the application architecture world. Before I tell you my secret tip for accelerating your learning experience, I want to tell you that I am currently in the process of making a full course on these 7 projects. It'll take you from zero to being a software engineer who has designed event-driven architectures, designed databases, and implemented fully authenticated serverless applications. If you're interested in leveling up your serverless game, then I'm offering an early bird discount, and that means you'll get access to every single one of the projects as they're released. If you're interested in that, then there is a link in the description where you can sign up. You can also download a PDF which gives you all of the details that are covered in this video, from each project to the architecture, and the link to download that free PDF is in the description below. But now we're going to move on to that super powerful tip to accelerate your learning, and that is to get your project working and then move on. It is super easy to get a project working and then spend days and days making it look beautiful or fixing small bugs or tweaking things to try and make it look perfect. If it's not helping you to grow and it's not making you learn new things, then you should skip that part. This doesn't just apply to the front end kind of things. If you're doing a project learning about event-driven architecture and there's a bug in one of your lambdas, but your application kind of works, then spending a day chasing down that bug isn't going to be helping you develop and learn these new event-driven skills. So just move on. You don't know how many of my old projects are kind of half working or have a really ugly UI because I learned what I needed to learn and I moved on. This will mean that you can spend time on the things that really matter, which will accelerate you to being a really good serverless engineer even faster. If you have liked this video, then make sure to smash that like button, as it really helps share this video with more software developers just like yourselves. And hopefully I'll see you in the next video.